Hi guys, so today we're going to go a little further into composing functions, composition of functions. Um, one thing I do want to note is that composition of functions you will see as f of g of x or f of g of x. Since this is an open circle, this doesn't mean that it's being multiplied. So just make sure that you look at the circle. If it's closed or open, if it's open, it is composition of functions. And composition of functions means you're going to use substitution, not multiplication. So you always start inside of the parentheses. So g of x is what we're substituting in the place of x for the f function. So we're using the f function, f of x equals 4x minus 7. Notice that the only thing different in the question is that instead of x in the parentheses, you have g of x in the parentheses. So outside the parentheses tells us what function to use. Inside the parentheses tells us what we're going to substitute. So I'm going to bring everything down exactly the same, the 4, the negative 7. The only thing I'm going to replace is the x. Just like in the parentheses, they replace the x with g of x. I'm going to replace this x with the actual expression for g of x, which is 2x minus 1. Notice the parentheses as well. So from here, I'm just going to distribute, and this will give me 8x minus 4. Bring down the minus 7. And after combining like terms, you have 8x minus 11. So this is going to be f of g of x. We have our function, and now we're finding the domain and range of it. Well, if you look at x to the first power here, this correlates perfectly again with mx plus b. This is a linear function. Now for domain, keep in mind, sorry, I forgot I can't draw a straight line. So for domain, remember, those are all the values of x. So remembering the lessons on domain, usually you can use any number in the x value. The only restrictions occur when you have a rational function, which is a fraction because you can't have a zero denominator, and when you have a square root or an even root because you can't have a negative value there, and also with logs. But we don't have that in this case. We just have a line. Okay, so there's the y-intercept, negative 11. And the slope is 8 over 1, so I'm going to go up 8 over 1. It's just a little sketch, nothing exact here, but this is what the line looks like. Um, and if you see, all the x values are being used. There is not one x value that can't be plugged in here, and it would give me an answer of undefined. So I could plug negative values into x, positive, 0. So the domain would be all real numbers. And for range, we've gotten into the habit of looking at that from a graphing approach. So if you look as the y values go out, they also head downwards towards where x is where y is negative infinity. And as I'm moving up the y-axis, this line will also keep going up and out, also towards positive infinity. So the range would also be all real numbers. All right, moving on from here, we're going to go with g of f of x this time. So remember that outside tells you which function you're going to use. We're using the function for g. We're just replacing the x with f of x. So instead of x plus 2, it will say, we're going to bring down the plus 2, but I'm just going to replace the x with f of x. So I'm going to replace this x with f of x, which is 1 over x squared minus 16. Now, in case you haven't seen adding and subtracting fractions video, just make sure you go through it. You can still do common denominators. That is perfectly fine. I add my fractions and subtract fractions a different way. So fraction form of 2 is 2 over 1. I use what I call crisscross applesauce. So criss, 1 times 1 gives me 1. Plus, because there's a plus in the middle, I should note before you start, make sure that everything expression-wise is in parentheses. So continuing on, Chris plus, because there's a plus in the middle, cross 2 times x minus 16. I'll worry about, or squared minus 16. I'll worry about multiplying that later. So I have Chris cross over applesauce. 1 times x squared minus 16, which just to make sure everything's thorough, I'm just going to write that down anyway, the 1. All right, so from here, I'm going to simplify. I'm going to bring down the 1 and then distribute the 2. So I have 2x squared minus 32. And in the denominator, if I distribute that 1, it's still going to give me x squared minus 16. So combining like terms in the numerator, the 2x squared comes down. I have 1 minus 32, which is negative 31, over x squared minus 16. Okay, so this is that straight line. I warned you guys about that. G of f of x. So I have g of f of x, but the question is not what g of f of x is, it's what's the domain of it. So the domain, again, are all the values that x can be. We know that this has a restriction because it's a fraction, so we're just going to find the values that x cannot be by looking at its vertical asymptote. Vertical asymptote, zeros of the denominator, meaning I'm just going to set my denominator equal to 0. Now, this is actually a difference of perfect squares. If you're not familiar with the difference of perfect squares, I will show you how to factor it, but just in case you don't remember how to factor it, because I guess the toughest part of factoring a difference of perfect squares is remembering it, just keep in mind that it is a quadratic function here. So, you're missing the x, so you could always put 0x in place of it and just factor from there. So these two mean the same thing. But if you have a difference of perfect squares, one is plus, one is minus, and you square root each one. So the square root of x squared is x, and the square root of 16 is 4. And you can always FOIL it and check, and it will bring you right back up to x squared minus 16. So factor it, the other side is 0. That means I'm going to set each parentheses equal to 0. And I will get x equals negative 4 and x equals positive 4. So these are the two values that would make my denominator 0. So those are the two values that x cannot be. All right, guys, hope this helps.